All right. Prove that between two consecutive roots of f of x equals 1 minus e to the x sine of x, there exists at least one root of g of x, which is 1 plus e to the x cos x. Okay. So first, we want to establish two consecutive roots of f of x. And so I will let x1 be less than x2 such that f of x1 is equal to f of x2 are equal to 0 because they are roots. And now we want to establish they are consecutive roots such that f of x1 equals f of x2 is equal to 0. And for x between x1 and x2, f of x is never 0. So this ensures that they are consecutive roots. There's no root in between x1 and x2. Okay, and now we notice that f of x and g of x, well, one is sine, one is cos, which the derivative of sine is cos. So I will take the, well, first we will look at f of x1, note f of x1 is equal to 1 minus e x1 sine x1, and similarly, this is equal to 0. Similarly, f of x2 is equal to 1 minus e to the x2 sine x2, which is equal to 0. So we have these two equations, and I'm going to take that equation and I'm going to multiply by e to the negative x, and I'm going to start just using x instead of x1s and x2s. And so I get, let's see, e to the negative x minus sine x. Yep. And I'm going to define this. Define h of x to be this. And we can note that h of x is just this manipulated. And so if I were to put in x1 here, well, we'd just get this out. And so let's take the derivative of h of x first, I suppose. So h prime of x is equal to negative e to the negative x minus cos x. Okay. So this is closer to what we want, and we know that if we were to plug in x1 into this, I see. From here, we note that h of x1 is equal to, well, it's essentially f of x1, because I just took f of x1 and I multiplied it by e to the negative x. And so h of x1 is going to give me 0. And h of x2, similarly, it will also give me 0, because all I'm doing is I'm putting in x2. Thus, by Rolle's theorem, there exists a C between x1 and x2 such that h prime of c is equal to 0. Thus, well, we know h prime of c is just this, but we plug in 0. So we get negative e to the negative c minus cos of c is equal to 0, which what I'll do is I'll add that over and I'll add that over to get e to the negative c plus cos c equals 0. And once more, I'll multiply by e to the c now. So this implies that 1 plus e to the c cos c is equal to 0. And we notice that this is g of c. Thus, so there's a root at g of c. There exists at least one root at g of c. Thus, there exists at least one root of g of x. And we're finished.